let's go over the homework number 1. In the homework number 1, there were 3 problems, right? In problem 1, I asked you essentially to enter this data into the clean, brand new SPSS data file. So you are a meteorologist who wants to track weather conditions in the city of New York. Every day you record the following data. Day of the week, and I believe there is a mistake there, right? 0, if 0 is Sunday, there are 7 days, right? Then last day, Saturday, should be labeled not 7 but 6, right? Okay, high temperature every day, low temperature every day, and then there are 2 flag variables, right? Nominal variables, kind of yes or no. Variable called sun, tracks how sunny was the day. 0, mostly not sunny, so it's overcast or just plain raining, right? Or 1 stands for the most day it was sunny. And another variable, rain. Same thing, 0, mostly there was no rain, okay? And 1, most of the day there was rain. So this is the data. Okay, so how do you do that? First you switch, like you open the empty data file from SPSS, right? And the first thing that you do is switch over to the variable view in order to define your variables. We have 5 of them, right? So variable number 1, I'm going to call, just like it's written in the homework assignment, day of the week, right? Day, and in the labels I'm going to say day of the week. Okay. Then I have some values, right, for this variable. So 0 stands for Sunday. Okay, and then I add that to the list. 1 is Monday. I add that to the list. 2 is Tuesday. Add. 3 is Wednesday. Okay. 4 is Thursday. 5 is Friday. And 6 stands for Saturday. Add that one, and then click OK. After that, all I have to do really is to set up my measure or data type. Which one do you think that is? Scale, ordinal, or nominal? You know, we can set it as nominal or ordinal, right? Because there is an order, right? First comes Sunday, and then Monday, etc. So nominal or ordinal would be fine in that case. All right. So that's our variable number 1. Variable number 2 is temperature high, right? And I'm going to type the variable name exactly as it is typed in the homework. Let me show you actually something. So if I try to put a space between 2 words, temp space high, and when I hit enter, trying to save that value, SPSS will tell me that variable name contains an illegal character. So there should be no spaces, okay? All variable names should be continuous, okay? And later on, when you get into the School of Business, I can tell you, because I'm teaching this course, okay, kind of in the School of Business, MIS, Management Information Systems. We're going to deal with databases, okay, in the MIS course. That's exactly also what happens when you try to create column name in the database. Strictly speaking, I mean, spaces are allowed in the column names, but then you have to do something fancy when you write database queries. So it's better to keep names of the variables without any spaces. So every time when you need to put a space in the computer world, you have to put really an underscore so that your name does not break between different parts. Okay, so it's a continuous string of characters. So I'm going to say temp underscore high, so I'm going to avoid spaces, right? And that's just a number, right? So I'm going to put that as a scale data type. Same thing with temperature low, temp underscore low. Here I'm going to say highest temperature of the day, right? Highest temperature of the day. And for the temp low, I'm going to say lowest temperature of the same day. And data type, just like the other one, is scale, right? Next one, I'm going to define sun variable. How sunny was the weather? How sunny was the weather? Okay. Values, right? I have two of them. 0, mostly not sunny. NOT, sunny. And then add 1 stands for mostly sunny. All right. And that one is nominal, right? Obviously. Not a number clearly, but nominal variable categories. Sunny or not sunny. And same, or similarly, I have rain variable. How rainy was the weather? Rainy was the weather. All right, and the values, very similar. 0 stands for mostly not rainy. Okay, and 1 stands for mostly rainy. A rainy day. Okay, add, and then click OK. And set the data type to nominal, just like for variable sunny, right? So now I can switch to the data view, and here is my template with 5 columns named just like I defined. And after that, I can go ahead and enter the data that I'm given. So day number 1 was Sunday, and that is 0, right? In my classification, highest temperature was 50, lowest was 45 during the day. It was mostly not sunny, so that means I have to enter 0 in this column, right? And it was mostly rainy, which means in the last column for rain, I have to enter 1. And if I want to see the values, right, instead of numbers, then I have to click that button that switches between the numbers and the values, and that gives me the same view as I have over here in my picture in the homework, right? Sunday, highest 50, 45, mostly not sunny, and mostly rainy. Okay, and I can do similarly the rest of the week's day, right? So that was problem number 1. Fairly straightforward, right? After that, you have to save the file, name it with your last name, and just email it to me, okay? So this was exercise just to make sure that you can create the file from scratch, right? And fill it up with data. Define the variables first, and then fill it up with data, okay? Any questions about problem number 1 on the homework? That was fairly straightforward. I didn't look at your homeworks yet, so everybody got that part? Okay, good. All right, let's take a look at the problem number 2. Problem number 2 was about Red Lobster restaurant, right? Conducts regular surveys of customers to monitor how they're doing. One of the questions they ask customers is, please rate the overall quality of your last visit. And they offer 5-point scale, right? 1 being poor, 2 fair, 3 good, 4 very good, and 5 excellent. So the responses are recorded in the file Red Lobster. Let me go ahead and open the file Red Lobster. There it is. So when I fire it up, here is my file. Okay. And number 1, what data type is used in the study? Well, we have 3 options, right? It can be either scale or numerical or interval data. And that's clearly not it, right? Even though 1, 2, 3, 4, 5, the responses on the scale 1, 2, 3, 4, 5 are technically numbers, but they really stand for categories, right? So therefore, we can't really compute any means or standard deviations, nothing like that, right? So therefore, we're dealing with ordinal data, right? Because categories are ordered. Poor is the worst category, and excellent is the best category. Okay, question B. Fill in the table below. For different responses, compute their frequencies. How many times customers who were surveyed answered poor, fair, good, very good, etc., right? And also percentages. Okay, so how do I do that? I go to the Analyze menu, right? Descriptive statistics, and then go to frequencies, okay? And in the frequencies, I have to tell SPSS that this is the variable that I'm looking at, okay? And also, I'm asking for charts, right? What kind of charts? Bar chart, right? And then I click Continue, click OK, and here is the result of the analysis. It's in the output window, right? Just like before. So essentially, the table that I'm looking for with frequencies and percents is automatically created, quite literally in like 3 or 4 clicks by SPSS, right? So, for example, my total sample size was 221, right? I can see it from here. And out of these 221 responses, 17 customers said that they didn't have a good experience at all, right? Poor. That represents 7.7% of your sample, okay? Excellent, on the other hand, 24 said it was excellent, and that is 10.9% out of 221, right? Okay. Any questions about this part? We did that in class, right? So that should be fairly straightforward. Okay, and then I'm asking you over here in the next couple of questions to compute some probabilities, right? So percents of the responses, of every response that we computed using SPSS can also be viewed as the probability. That's pretty much how you define probability based on, well, experiment. This is an experiment, right? I take a sample of customers, and out of 221, in this case, I'm computing what percentage said poor, what percentage said fair, etc., etc. That can be viewed as the probability that a randomly selected customer, okay, will rate the experience at Red Lobster restaurant as poor. So I have 7.7% chance, right? Fair, there is 19.5% chance, okay, that the experience will be rated as fair. So what is the likelihood that a randomly selected customer will rate restaurant service as good or higher? So in other words, the answer can be either good, right, or very good, or excellent, okay? So how do I compute this probability? Let me type it right here. Probability of good or higher, okay? So all I have to do is add the probabilities of the corresponding answers, right? So it's probability that the response will be good, plus probability that the response will be very good, plus the probability that the response will be excellent. So in other words, I have to add 0.312, right? That's my probability of response good, 0.312, plus, next one is very good, 0.308. Next one is excellent, and that would be 0.109. 109. And then I have to add these values together, so it's going to be probably around 73%, right? I can't compute that right now that quickly, but if you use calculator, that's going to be roughly 72-point-something%, right? So that's question C. And question D, what is the probability that a randomly selected customer will rate restaurant service anything except good or excellent? So except good or excellent, except poor, I'm sorry, or excellent. Poor is the lowest response, excellent is the highest response, so therefore we're looking at kind of responses in the middle, right? So probability of, what I'm looking to compute is probability of response fair, right? Plus probability of response good, plus probability of response very good, okay? And it's just the sum of these three numbers. So for fair we have 0.195, plus for good we have 0.312, and for very good we have 0.308. 308. Okay, and that apparently comes up also around 70% chance or something like that. Yeah, I can't quite compute that right now, so you have to use calculator for that one, right? Any questions about problem number 2? Yeah, it was fairly straightforward, right? And problem number 3 was about a different data set. Insurance claims adjusters would like to investigate how the dollar values of the car accident claims are distributed. So what he does is he collects a random sample of insurance claims just recently filed, and records the dollar value of the final insurance payment. So let's open up the file with insurance claims data. And there it is. Okay. So let me bring up my homework again. All right. What type of data is collected in the study? So the first customer was paid $1,492, right? Next was $1,516. Clearly, we're dealing with interval or scale data, right? These are actually numbers, right? We cannot just randomly reassign them. It is what it is, dollar values, right? Construct the tabular summary of the data. Use 0 as the lower boundary and use the class width of 500. Okay, so I'm going to construct the histogram, okay? And from the histogram, I will be able to find out these frequencies. So I go to the analyze, descriptive statistics, frequencies again, right? And just carry my variable over here on the right side. And I'm asking for charts, right? So I'm asking for the histogram, and I want frequencies. Okay, so continue. And I click OK, and here is the histogram for me, right? Where is it? Processing still. Okay, so here is my histogram, okay? It looks a little bit different from what I need, right? Because it looks like between $0 and $1,000, I have 1, 2, 3, 4, 5, 6, 7, an awkward number, right? So that means that the width of every bean, these are called classes or beans, right? The width of every bean is like $140 something, right? And I need it to be 500, right? So what I do is double click on this histogram, right? And it shows up in the chart editor. And now I just double click on one of the bars again, and it opens up the properties window, right? So all I have to do really is for the horizontal axis, set the custom interval width, and that should be 500, right? Just like it says in the problem. And then I say apply, and it redraws the histogram for me, right? So I can close that window now and close the chart editor. So now my histogram is, oh, I forgot one thing, right? I forgot to add the labels, right? Yeah, so let's go back, and I'm going to click on show data labels. And that's what it does. All right. So it looks like between 0 and 500, I have what's the number? 87 looks like, right? So total number of claims in my sample is 744, right? That's what it says. So in the first bin, I have 87 responses. In the second bin, between 500 and 1,000, I have 307 responses, then 202, then 84, then 39, then 15, then I have 6, and apparently the last two are count of 2, frequency of 2, and another 2. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different bins, and that's what I'm supposed to post over here. Okay? All right, and the last question asks you to look at the histogram and characterize it with respect to modality and symmetry. And if the distribution is not symmetric, in other words, it's skewed, then tell which way it's skewed, right or left, and also provide a plain English explanation, the business reason. Why do you think that happens? Well, first of all, let's start with modality. What do we mean by modality? Modality tells you how many peaks the histogram has, right? And this one clearly has only one peak, right? Distribution has only one peak. So that means that this histogram is unimodal, right? Symmetry. Does it look like symmetric histogram to you? No, not at all, right? It is skewed, but in which direction? In the positive or negative direction? Positive, right? Because the long tail extends to the right, okay, to the positive direction of the horizontal axis, okay? So it's a positively or right skewed histogram. Well, if this is the case, then why do we think that is? Well, dollar values are proportional to the severity of the accident, right? The more severe the collision, the more the insurance payment is going to be, right? So from your personal experience, let me ask you this question. From your personal experience, on the road, if you see a collision, do you see mostly serious collisions with bad damage to the cars, or mostly like a brush up, fender bender kind of thing? Mostly not very serious, right? Thank God for that, because otherwise driving would be very dangerous, right? Experience. So most of the accidents, somebody bumps, into somebody, you just have body damage, right? So a dent in the bumper or something like that, right? So we have very few accidents that are, associated with total loss of the car, right? When the whole front end of the car is completely smashed, the engine is gone, etc., etc. So therefore, if you look at the distribution, fender benders are typically not very expensive to fix, right? So a few $100s maybe. So therefore, you have a lot of accidents that are under $1,000 values, right? Well, in fact, between $500 to $1,000 is your tallest bar, right? That's the most frequent value of the insurance payment, it looks like, okay? And as you get into more and more severe accidents that are more expensive, right, you see fewer and fewer of them, right? So if you get to the area of really expensive accidents, like several $1,000s, $4,000, $5,000, $10,000, then practically you don't have them, right? So the frequency is very low for these accidents. Thank God for that, right? So this distribution basically tells you that you have more accidents that are not very expensive, like fender bender, minor things, right, as opposed to high value accidents. Thank God for that, right? So it follows, the distribution follows how severe is the collision, right? We have a lot of not so severe collisions and very few of pretty severe collisions, okay? So that would be a business explanation of why that happens. Any questions, ladies and gentlemen, about problem number 3 on the homework? Was it easy? More or less straightforward? Okay, good. All right.